This is CP2 lesson 4 notes, you guys. And at the end of this, I'm going to draw you a piece of artwork. I don't know what it is yet, so we'll just have to wait and see. For those of you on the web, it'll be good. It'll be artistic, and it'll be mathematical, I think. We'll see where it goes. So surprise at the end. Follow through. Like, subscribe, comment later. Okay, so let's understand properties of inscribed angles, including when they intercept the same arc or a semicircle, and understand the angle relationships in a cyclic quadrilateral. Oh, let's go. Okay, so look at these two angles. I want you to talk to a neighbor for about 15 seconds about the difference between the green and the red angle. Ready, set, talk to each other. All right, so which of these two angles is an inscribed angle? Angle CAO or CAR, right? Angle CAR is an inscribed angle. Inscribed angle, okay? And that's because this point is on the circle. Okay, so an inscribed angle. And that makes our central angle, our other angle, our central angle would be angle COR. Is it okay if I call that angle ROC? Yeah, it's okay. Now, what's the difference in their measures? What would the measure of angle CAR be? Yeah, it would equal 31 degrees. It'd be half of the intercepted arc, right? And since they both intercept the same arc, they're both related to that same arc measure. So what would the measure of angle ROC equal? 62. Okay, cool. So if two angles intercept the same arc, they have a relationship, but they're going to be different because one would have to be an inscribed and one would be a central angle. Let's continue. So if we were to find the measure of ACB, we would need to know this arc measure first because it would be half of this arc measure. So what would that arc's measure be? Yeah, that'd be 105, and then I just divide that by 2 to get this angle measure, which would be 52.5. So it's all a relationship between angle and arc that's intercepted. Most of the time, we'll give you enough information to solve. Actually, all the time we will. It just sometimes it might be a little bit more difficult than others. Okay, let's continue. Here's a good one. Why don't you take a minute or two and see if you can come up with the measure of angle X and the measure of arc, this arc from here to here. I want to know the measure of that arc, which would be Y, and I want to know the measure of this angle, which may or may not be related to that arc measure. So with one of the other childs near, all right, let's get back to it and see how we did so far. Did anybody find X? Reed, what'd you get?
I got 47.5.
How'd you get that?
Since X, you probably divide the circle in half, and 85 minus 180.
Reed, you're absolutely right. That's one way you can do it. Here's a way that I like to do it. If this angle right here is X, then doesn't that make this arc 2X? Right? And wouldn't 2X plus 85 have to equal half the circle? Right? So that's how I go about this, and I do the same thing Reed did. And I take 2X equals, what was that, 95? And I divide by 2, and I get 47.5. So I see that X is 47.5. Now that should give away on this second portion the fact that if this is 30, then this arc here would be 60. And 60 plus Y has to equal half the circle as well. So it looks like Y has to equal 120. More to do here. All right, angles, inscribed angles intercepting the same arc. Okay, so this is something that you need to kind of just, you know, when you look at artwork sometimes and you need to just like kind of sit back and squint a little bit, and then it makes more sense. Okay, I want you to do that on this. Now I want to look at this arc A to B. Okay, and I want to do this in a couple of ways. This angle right here Would you agree the endpoints of that inscribed angle are the endpoints of arc AB? Right. And I'm going to do the same thing here with this angle. So if two arcs intercept the exact same, two angles intercept the same arc, what do we know about their measures? Yeah, read. Yeah, they got to be the same. Now, I don't know what the measures are, so I would have to have some value for the measure of arc AB. All right, let's say I had the measure of arc AB is 92. Right? Then I could divide that in half, and I'd know both x and y are 92. Okay, so I do have to have more information to find the actual value. So this would be 46 degrees, and this would be 46 degrees. But the main concept I'm trying to get across to you is that if those two angles, inscribed angles, intercept the same arc, they'll have the same measure. Okay, cool. So let's move on to this problem here. Okay, now an inscribed semicircle. This is really cool, and here's why. Right. What do you notice about the arc measure for this inscribed angle? What would the measure of that arc be? This one. 180. So what is this angle right here? 90. Okay, any triangle or any angle that's inscribed in a semicircle is going to have a 90-degree angle. Likewise here, this angle has an arc measure of 180 as well, which makes this angle 90. Cool. Now this piece might blow you away a little bit, but let's take this quadrilateral. I'm going to see if I can use technology to my advantage here. Let's go like this and like this. Let's duplicate it and draw it over here. It didn't come over the way I wanted it, but I can erase them. Here's the quadrilateral that we've just highlighted, and we've said that these two angles are 90. So what do I know about this angle here, x and y? What do the four angles have to add up to? 360. So what's true about x and y? They have to add to what? 180, right? Because I've got two 90s plus x plus y equals 360. Well, I know two 90s is 180. Therefore, x plus y has to equal 180. And that's always true. If you have an inscribed quadrilateral, let me sketch one here for you. Pretty decent circle. Ooh, that was really good. I'm going to give myself an A and an extra 10 grams of protein at lunch. Okay, fine. If I inscribe a quadrilateral, what will x and y have to add up to? You know it. 180. What will a and b have to add up to? 180. Does it mean that any of them are 90s? Not necessarily, but they could be, right? But I do know this. A plus b will always equal 180 degrees, and x plus y will always equal 180 degrees. That's a nice little shortcut that's available for you. You're welcome. That's for free. This is so ridiculous. It's ridiculously mathematical. All right, here we go. We just talked about this. What's the quadrilateral conjecture? Why do I have the same writing underneath that? That doesn't make any sense. Basically, it's this. Opposite angles in a cyclic quadrilateral add to 180. They're supplementary, right? Angles across from each other add up to 180. That's what it is. I don't know what this GeoGebra video is. Do you want to watch it? Yeah. Should we see what it is? It's probably outdated now. Hello, open, please. Oh, there it is. GeoGebra tube. What is this? show hint. Straight lines, da da da, intersect, da 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 da. Find the relationship between P and Q. Angle P and angle Q. Yeah, they add to 180. That's cool. Wait, do they? That doesn't look right. Oh, got to drag C over to here. Oh, there we go. Oh, weird. Do 98.95 and 82.37, are they about 180? If I can get this right on there. Yeah, they are. Right? Doesn't matter where they are. What if they're right across from each other in the circle, making a... How could I make a 90? Let's see if I can make a 90. I can't right now. It's cool. Okay. That was a really... Yeah, that was a waste. I'm going to delete that next year. Okay. Let's see how many more I got here. Oh, last one I want to do. Hey. No. Sit down. No. You snuck... You tried to sneak that in. You tried to sneak that in. It's not working. No, I said yeah to myself. Hey, have children. Then you'll talk to yourself a lot, especially in Walmart and Mac and Tunes and all those places. You're like, oh my gosh. Now, I'm recording this, so I'm not going to get into story time right now yet. Okay. Last thing that I want, I believe, Kylie, I believe. Yes, last thing I want to go over is this thing called the parallel lines conjecture. If you have parallel lines that are secant lines, or chords for that matter, in a circle, what could I say about these two arcs? Arc BC and arc AB. Yeah, they're congruent, right? Does that make these two arcs congruent? No, not necessarily. Potentially, but not in this case, right? How would this help me if I knew that these arcs were, I don't know, let's say 15 degrees? And let's say that this went through the center of the circle. Let's call that, oh. Would I know the measure of this arc over here, measure of arc CD? That'd be 180, right? Because it's half the circle. And then I could do a little bit of work. I could take 30 away from 180, and it looks like arc AB would be 150. Okay, so there's a little bit of common sense going into this. But parallel lines that cut through a circle will create, on the inside of the parallel lines, congruent arc measures. It's just kind of a symmetry thing that you need to get used to. Okay. Let's pause this and